All right, let's find the measures of central tendencies using SPSS. So this page here with the actual numbers on it, this is what we call the data view. Hold on. See, it says data view. Just remember, numbers are data view. Variable view is where you go in and you name the variable, tell the computer what type it is, and all this other stuff we'll go over later when we get to that point. But let's go back to, it doesn't matter whether we're in data view or variable view, but let's go to analyze. There are many ways to get things done in SPSS. So to find the measures of central tendency, I'm going to go to Analyze, Descriptive Statistics, Descriptives again. I'm going to move the variable in question over to the variable box. With this one, under Descriptives, I want you to click the Save the Standardized Variables. So when you go back to your data page, you're going to have a new list of numbers, and they're going to be the z-scores for each individual score. And again, we'll get around to that. Let's check the options box, see what kind of options we have here. Now, the computer normally picks everything for you, but I want you to get the mean, the standard deviation, the range, and the variance. Variance is all important in statistics. We want the standard error of the mean. We're going to check the kurtosis and skewness that has to do with normality. And the rest of that stuff we don't need. Click OK. And click OK. And then you get an output sheet. This is a different file. The first one with the data on it is an SAV file. The output sheet is an SPV file. I'll say that again. Data sheet, SAV file, output sheet, SPV. So just remember the P is for output. So let's take a look at what we got here. So there was 100 pieces of data. The range was 98. In other words, if you subtract the maximum from the minimum, you get 98. The average was about 61.4. Standard error is about 2. Standard deviation is about 20. The variance is about 400. And the skewness and the kurtosis. What you're supposed to do is you're supposed to take the statistic divided by the standard error. If that number is greater than 2 or less than -2, then you're probably dealing with a violation of normality. It looks like it might be a little bit skewed here, and it is not kurtotic. Okay, skewed means that it's lopsided. There's either too many on one side or the other of the middle of the graph. Kurtotic means it's got too many tall spikes or not enough tall spikes, but it might be a little bit skewed. I'm going to show you in a second here how to officially check if it's skewed. But after you get this box, okay, this output box, I want you to click on it, right-click, copy. You're going to paste it into your homework assignment. Okay, you just click it up here. I want you to write down the exact steps on SPSS, how you got to the box, right? Analyze, descriptives. Right-click, paste. You'll notice the box is too big. It goes off the page over here. Okay, I'm going to show you a big trick. You find a little arrow here, right-click. You're going to, hold on, let me fit it so you can see it. That should fit. So you click on the document, you right-click until it's highlighted. You're going to put in auto-fit to window. Bam. What it does is it shrinks everything down so it fits on very nicely on a Microsoft document. Okay, so there's the first part. Second part coming up. So remember the little box that you clicked that said Save Variable as Standardized Z-Score? We go back to the actual data page, the one with the data on it. You'll notice, let me pull this up, that the computer created a new variable for you. There's Z-scores. So the person that scored a 1, their Z-score is actually -3, blah, blah, blah. The person who scored a 2 is -2.9, blah, blah, blah. So right-click on the Z-scores and put them in descending order. That means it starts with the largest. So this is a great way to identify any outliers in your data set. Remember, an outlier is something that's just either way big or way small than the rest of these guys. So the cutoff is 1.96. Real close rule of thumb is 2. I will take 2, right? Because the difference between 2 and 1.96 is only 0.04 of a point, which is tiny. So you're basically looking for scores greater than 2 or less than -2. So there are no outliers above 2. But now let's re-click sort ascending. So it starts with the smallest. And you have 2 outliers. So in other words, The person who scored a 1 and a 2, they are officially outliers. Now, it's up to you. You can delete them before you run your tests, or you can leave them in. It just there should be some kind of theory behind it, but that comes later on in the course. Okay, so you got 2 outliers, which may be responsible for the skewness or not, but again, we'll hit that later. So what I want you to do is to write down what the actual outliers were. So just go ahead and write copy again. Go back to your homework sheet, and then type in outliers. Oops, spell it right. You're probably going to get an error on Microsoft Word. Oh, not this time. Okay, never mind. But those are the outliers. So the person who scored 1 and 2, they're both outliers. Their z-scores say they're way under the mean. So next I'm going to show you how to do histograms. Hold on. So back to the SPSS data sheet. Again, it doesn't matter if you're in a variable view or data view. You're going to go to Analyze, Descriptives. This time I want you to go to Explore and take the SPSS exam scores, not the z-scores, just the regular data. Click it over to the dependent box. Click on the statistics button, and it's going to ask you what you want. Descriptives, again, that's the mean, the standard deviation, range, variance, that kind of stuff. Do not click the outlier button here. It is not factual per se. It will give you the minimums and the maximums, that kind of thing, but that doesn't necessarily mean they're outliers. So again, do not click that. Plots. All right, normally the stem and leaf plot is clicked. Unclick that. We really don't use stem and leaf plots anymore, but we do use histograms. So histograms, make sure that one's clicked. Normality plot with tests. That's very, very important. It's going to give you what we call the Kolmogorov-Smirnov test of normality, and that is the official decider whether a set of data is skewed or not. Okay, so again, I'll show you that as it comes out. So we hit continue and options, don't care. Click OK. And you get your output. So again, you get how many pieces of data were in there, how many were missing. So we get the same means, median, variance, standard deviation, etc., etc. This is a money box right here. Test of normality. So according to the Kolmogorov-Smirnov test or the Shapiro-Wilk, if this significance number was less than 0.05, that means you violated the assumption of normality. But it was not less than 0.05, so you did not, according to Kolmogorov, you did not violate the assumption of normality. To Shapiro-Wilk, you almost did. Okay, Shapiro-Wilk, you're supposed to use with a much smaller sample size, but we're not gonna fight about that now. So again, the KS test. If this is less than 0.05, you have violated. Here's a histogram of the data. You can see your little outliers just sticking out like a sore thumb here. Okay, you can get rid of them if you want to, but according to the Kolmogorov-Smirnov test, it is normal enough. And here's another normality test. It's called the normal QQ plots. So these little circles are pieces of data, and if the data set is normal, they should wrap around this thing like a snake. Again, this identifies a couple of outliers. Okay, that's your guys that scored 1 and 2. The detrended, we don't use that. Just delete it. Click and delete it. And here is a box plot. Let me pull it up so you can see it. And it's pretty symmetrical. So that's another way to test for normality. Remember, a box plot breaks up the data into quartiles. So between the first horizontal line and the second one, 25% of the data was between, 78 and 99. And the third quartile was between 78 and, 70. But that's how the quartiles work on a box plot. And again, it will identify outliers for you. So this is person number 1 and person number 2 down here. So let me show you how to cut and paste this stuff into your Microsoft document. You simply go up to where you want to start, right click. It should be outlined in black. Scroll down where you want to stop. Hit the shift key and click at the same time. Everything gets highlighted on the side that you're about to copy here. Right click, copy, jump over to your Microsoft Word, and then you're going to paste it in here. Same thing. You're going to look to see if any of the tables go off the board, and they don't. And this, you'll notice this first box here, it has all this computer data that you really don't need to know. So just right-click and cut. Get rid of it. But again, I still want how you got there, so type it in. Hold on. So that's how you got there. Analyze, Descriptives, Explore, and I just showed you what you were exploring, and everything's there. So that's it for the first homework assignment. Let me know if you get stuck. I will talk to you soon. MGZ, out.